Composite or composite objects, so made up of more than one object here. Determine the surface area and volume of each of the following shapes. Round all answers to the nearest tenth. Now this is something that in class we'll be doing over a couple of days, but I'm going to go through the entire worksheet in just one lesson, so this might be a little long. Okay, surface area. We have two surface areas we want to figure out. We want the surface area of the cone, but not including the circular base. So we just want the lateral surface area of the cone and the surface area of the hemisphere, and again, not including the base. So we're looking at the exposed surface area of this object, which will just be the lateral area of the cone and the lateral area of the hemisphere. So surface area will be SA lat cone plus SA lat hemisphere, right? So the lateral area of the cone plus the lateral area of the hemisphere. Cone is pi r s, remember, just the lateral area, and this is 1/2 of the surface area of a sphere, which is 1/2 of 4 pi r squared. So we get, we know pi, well, pi is just pi. For the cone, the radius is 6. And for the cone, the slant height is not known. So, okay, I'm going to go do a little calculation up here. We've got the 6, we've got the 12. So there's our 6, there's our 12, because we've got the height of the cone. This is the slant height. So s squared is 6 squared plus 12 squared. And I'm going to shortcut this just a little. Just go straight to the answer. S is the square root of 180, right? And I think you can follow and see where that comes from. 36 plus 144 is 180. So S, I need the root of 180. Plus, 1/2 times 4 is 2, so let's just go with 2 pi and then 6 squared. Okay, so this could simplify to 72 pi, but we've got this, and we're just going to plug it into our calculator, which I'm not going to do for you because there is nothing really special here. Just remember that you type the pi, then times 6 times root 180, then you move out from under the root sign before you do the plus 2 pi times 6 squared, and double check, you should get 479.1 square centimeters. Okay, volume, when we go to work out the volume of this, we want the whole volume of the cone, we want the whole volume of the hemisphere. Okay, so volume is volume cone plus volume hemisphere. The formula for volume of a cone is 1/3 pi r squared h, and the formula for volume of a hemisphere is 1/2 that of a sphere, 4/3 pi r cubed. 1/3 pi 6 squared. H is 12. Okay, we don't need slant height here, we need the actual height of the cone. 1/2 times 4/3 is 2/3 pi 6 cubed. Okay, put away the calculators for a minute here. 6 squared is 36. 1/3 of 36 is 12, and 12 times 12 is 144. 6 squared is 36. 6 cubed. 6 cubed is 216. 1/3 of that is 72 times 2 is also 144. 144 plus 144, that's 2 gross. Actually, a gross is actually a dozen, which is 144. 288 and 288 pi, plug that in your calculator. Or, if we want it exact, this is the exact volume, right? You weren't asked for that, so you could simply have taken this, worked it out, gone straight down to here, and given 904.8 units centimeters cubed. That's our first one. Not too hard. Now, haha, hard. Okay, so what we have here, it's got like a dumbbell, right? And it's got two cylindrical ends, each the same size. So we need the surface areas of the two of them, but we have to subtract off this rounded area here, right? Because we don't have that. That's covered. So we are going to take the area of the cylinder minus the area of this little circle here, and then multiply it by 2 because there's two of them. And we're going to take the surface area of the lateral part of this cylinder because we don't have exposed ends. Okay, so our surface area. There are two of them. Surface area of a cylinder is 2 pi r squared, right? Because we've got these guys here. And, you know, let's give these, so let's go down here. Let's say R1 is 10 centimeters. And this is 3 centimeters, so R2 will be 1.5 centimeters. These have heights. This height, so that 4.5 centimeters, we'll call that H1, right, because it's part of this. And this 15 centimeters, that's H2. So I better specify. I'm going to do R1, 2 pi R1 squared. That's the outer side of this outer side and this outer side, plus, and the curved part of cylinder is 2 pi RH, but it's R1 H1. And from that, we need to subtract this little circular area here, right, which is pi r squared. But that's R2 squared. Okay, so that covers these two guys. Now we need the lateral surface area here. So we're going to go plus 2 pi R2 and H2. Okay, so we've specified, and so this is what we're doing one more time, right? We've got two of these large cylinders, like the weights on a dumbbell, and this is the handle in between. And these cylinders have a radius of 10 centimeter and a height of 4.5. And we've got the two faces, that's the 2 pi R1 squared. But we have to subtract once, and only once, right? Because it's not, this face is the full face, this full pi r squared, but we've got to subtract off this little guy here. That's being done here. And then this is the lateral surface area. There are two of them, right? One here, and then there's one of these guys, and we only need the lateral surface area. Okay, let's go plug in. So 2 pi R1 is 10 squared plus 2 pi R1 is 10 and H is 4.5. That's this guy, minus pi R2 is 1.5 squared. Close the bracket. So that's all of this. Then we need to add the lateral surface area of this guy, which will be 2 pi 1.5 15. And you know what? Just plug it into your calculator. Work it out. I got 1949.4 square centimeters. Okay, so if you have to go over this again, just back it up, go over it again. We have these two cylindrical shapes, right? And we want the full area of them, so 2 pi r squared plus 2 pi RH. But we need to subtract off this little circle here, right? That area is not covered, right? So we need to take it off, and that's using R2. Okay, let's meet up at volume. Often volumes are easier, right? Because we don't really have to worry about the fact that they're joined and that. We just need the volume of this and the volume of this. They're the same, so two volumes of these guys. Okay, and so just remember, R1 is 10 centimeters. This is a diameter of 3. R2 is 1.5 centimeters. The height of these guys, let's call that H1, and the height of this. So the volume V is 2 times V cylinder large plus V cylinder small. So that's 2 times. The volume of the cylinder is pi r squared h, so it's pi r1 squared h1 plus pi r2 squared h2. Formula, substitution, pi 10 squared 4.5 plus pi 1.5 squared 15. Plug into calculator. Work out 2933.5. Don't forget units. Lose marks if you don't have your units. Centimeters cubed. Okay, got some explaining to do here. What we have, imagine this is a solid block of metal, and then we've drilled 2 holes. If we want to do the surface area, we're looking at, well, let's say we want to paint this. I'd have to paint this surface and the bottom and that and the front. And when I go to paint the front, I don't need a full 200 square millimeters of paint, right? Because I'm subtracting out this circle, the area of this circle. Here, here, and then back there. And when we go to calculate volume, we will work out the volume of the whole thing and subtract off these 2 volumes. But let's start with surface area. So we need the surface area of the prism minus the 4 circles. But then wait, we also have to paint the inside of these circles, so we're going to add on the 2 cylinders. Okay, so the surface area of the prism minus these 4 circles plus the lateral surface area of these 2 cylinders, right? We don't need the ends. The ends are hollow. There is no end here. So the lateral surface area. Okay, so surface area is, so for the prism, it's 2 times length, width, plus length times height, plus width times height, right? So, you know, if we call this L, and we call this H, and we call this W, and we'll say here that the radius of that is 5 millimeters. Okay, so we're going to use a radius. So we've got 2 faces, front and back. We've got 2 top and bottom. We've got left side, right side, and then we need to subtract from that 4 circles. Right, front here, and the back circles as well. Those are off the surface area. Then we've got 2 cylinders, so plus 2, and the lateral surface area of a cylinder is 2 pi r(h), so 2 pi r. In this case, it's going to be W, right? Because W is the actual height of the cylinder, right? So the height is, which luckily they're the same, but you know, it's really the W, right? It's the width. Okay, plug in. Length times width, so 60 times 20. Plus length times height, 60 times, again, also 20. Plus width times height, which will be 20 times 20. Minus 4 pi. Our radius, in this case, is 5. Plus, let's write this down here so it doesn't run into it, 2 pi radius 5, and the height of the cylinder, which is actually the width of the prism, is a 20 there. Okay, so if we want some details, I mean, you know, we don't need a calculator yet. 60 times 20 is 1200, another 1200, and 400, minus 4. 5 squared is 25 times 4, so minus 100 pi, plus, what do we got here? 5 times 20 is 100, 200, 400, so plus 400 pi. So I don't exact value for this. What have we got? 2,800. So 2 times 2,800 plus 300 pi. So that's 5,600 plus 300 pi. And plug that into your calculator, or plug this into your calculator, right? But if we want exact values, this is an exact value expression for the surface area. Okay, so if we have to work out exact values, you have to do this. You have to work things out in terms of pi. You don't even need a calculator to do that, right? These numbers were all actually quite nice. Now you need a calculator. And we get 6, 5, 4, 2. And remember, always use the pi key. And now we bring in units. It's an area, so that's squared. Okay, so millimeters, everything's in millimeters, and then square millimeters. Okay, when we go to the volume of this, we take the volume of the prism and we will subtract off the volume of those two cylinders. Okay, so the volume of the prism, so V is equal to volume prism minus 2V sil, right, because there's two cylinders there. So the volume of a prism is length times width times height. And the volume of a cylinder is 2, well, the 2, because there's two of them. Volume of a cylinder is pi r squared. H, remember our H is actually in this case the W. So 60 times 20 times 20 minus 2 pi, our radius again is 5 squared, and H, or W, H for the cylinder, W on the diagram. Okay, 6 times 2 is 12, times 2 is 24, followed by 3 zeros. We got 25, times 2 is 50, times 20 is 1,000, so minus 1,000 pi. That's the exact value, right? And then you go to work that out. And, you know, this will be like 3,000 something, right? Like, well, actually it would be 3141.5. So like 3,100, that'll take this down to like 20,000 and change. So 2858.4 volume millimeters cubed, right? Always look for reasonableness in your answer. Remember, the fourth step in problem solving is look back. Is this reasonable? Well, 24,000, that's like over 3,000. Yeah, okay, that's reasonable. What's next? More surface areas. In this case, we have a pyramid, which is on a base. So surface area, we have the four faces. Okay, it's a right pyramid. That's 15. Since this is 30, that makes this 15. And we're going to have a slant height here. That's going to be the square root of 15 squared plus 15 squared. So S, give it a number, S1. It's the square root of 450. Because now, what have we got here? That's 10. You just can't draw very well. Okay, so that's 10, and this is 15, and this we'll call S2. So S2 will be the square root. It's the hypotenuse, right? So it's 15 squared plus 10 squared. S2 is the root of 325. All right, I barely started the problem, and already I've got calculations going on here. Okay, so what have we got? Well, we have these two faces here, which are the same. We have these two faces here, which are the same, right? This has a base of 30 and a slant height of S2. This has a base of 20 and a slant height of S1. There's two of those. We then have this face here, and there's two of those. This face here, and there's two of those. So we've got four of these guys. And then we've got the bottom, right, the base. Okay, and otherwise we assume that all of the rest of this is hollow, and then for our volume, which when things get easier, right, it's just the volume of this prism plus the volume of that pyramid. Okay, so surface area. We've got area, surface area equals 2 times. Okay, let's throw some numbers on here. If I called that S2, then I'm calling this B2. If I called this S1, then this is B1. This is, let's call this H1. Let's call this H2. And I think we've got all we need. So I have two faces, which are 1/2 B1 S1 plus two faces, which are 1/2 B2 S2. Okay, this is B1 S1, so the area of this triangle, which is also the same as that triangle, that's this area, so there's two of them. B2 S2 is the area of this face, the front face, and also the back face, so there's two of them. Now we've got this face, so let's call that B2H2. Okay, and there's two of them, B2H2, and there's two of these guys, which is B1S1, or sorry, B1H2, and we've got the base of the whole thing, which is B1, B2. Let's divide stuff off. Okay, let's go fill in some numbers. And we can do a little bit of simplification. So 2 times 1/2 is 1, right? So we've got B1 times S1. So 20 times S1, which is root 450. Extend the root sign out. Plus 2 times 1/2 is 1, so we've got B2 30 times S2, which is root 325, so 30 root 325. It's this guy, plus 2 times 30 times 5. Sorry, I'm going to go down here. I'm running out of room there. Plus 2 times B. Okay, what did I do? B2H2. Yeah, okay. Plus 2 times B1H2. So there's two of these guys, right? So that's 2 times 20 times 5. Plus the base at the bottom, right, which is 30 times 20. 30 times 20 equals, all right, what do we got? 20 root 450. Yeah, let's just do a little exact stuff here. Plus 30 root 325. Plus, that's 10 times 3, which is 300. That's 100 times 2, which is 200. And that's 30 times 20, which is 6, followed by 2 zeros. And, you know, we want an answer. Okay, so you can plug this into your calculator. Or you could have plugged this into your calculator. Maybe try it both ways. Just get a little practice doing things both ways. A little practice doing some calculation mentally, right? Easy, you know, 20 times, that's 100 times 2 is 200. That's 40 times 5 is 200. Okay, 2065.1 square centimeters volume. Okay, we need the volume of the pyramid, so V is equal to, well, let's do the volume of the prism plus volume of the pyramid. Volume of a prism, using our naming convention, will be B1 times B2 times H1. He thinks, going back to check the naming convention. No, that'll be an H2. Okay, hang on, let's go back, we'll okay, B1, B2, H2. B1, B2, H2, H1. Okay, plus pyramids, 1/3 the area of the base. So B1, B2 times the height H1. Fill in numbers, right? Maths, right? It's just formula. What formula we're using, let's substitute in, make sure we've got everything labeled correctly. or consistently, really. I don't care how you label these, just needs to be consistent. Okay, so numbers: 20 times 30 times 5 plus 1/3, 20 times 30 times 15. Put all your calculators, you don't need a calculator here. 5 times 20 is 100. Times 30, stick another 0 on, is 1,000, is 3,000. 1/3 of 30 is 10. 10 times 20 is 200. 2 times 15 is 30, and then we'll stick another couple of zeros on there. And we get 6,000 cubic centimeters. Okay, let's hit up the next one. And we are definitely going to take a little while longer here. On this one, I need to make a little edit here. This is not a correct number, so we are going to go work out the correct number for that, and here's how we're going to do it. We're going to draw in a height. So there's the height of the original pyramid, right? And then this goes out here. Let's make that 10. That already is 10. It's labeled as 10. Let's just leave it. Okay, so here is what we have. These triangles, this big triangle here, the 14 and the 10 and whatever this is, will be similar to this triangle, right? They both have 90s here. They have this same angle. It's on the same line. They have this same angle up here. They must be similar triangles. So we're going to work out this radius based on a similar triangle. And we are going to call this R2. We're going to call this R1. And we're going to call this S1. And we're going to call this S2 for slant height 2. And we're going to actually need some heights later on, so let's work some stuff out now. So I have a triangle that's got 10, 14. This will be the square root of 14 squared minus 10 squared, which is the root of 96. This other triangle has a slant height of 5, and this is R2. So we're going to set up similar triangles, right? We are going to say that R2, the base of this triangle, is to its height. So let's go over here. R2 over 5 must be in the same ratio as 10 over 14. So R2 is 5 times 10 over 14. R2 is 3.571, 3.571, dot, dot, dot. Never round. Okay, so I'm going to turn this on. Let's clear this, so we're just doing it for here. So 5 times 10 divided by 14. Enter. Okay, so we're going to keep that number. We're actually going to have to use it a couple of times. Since we're going to have to use it a couple of times, let's put it somewhere. So I'm going to say store, hit the alpha key, alpha A. So I'm going to say take the answer and put it into A. Right? So now I can use this number again anytime. So if I go like 2 and then alpha A, 2 times A, right, we're going to get what? Like 7 point something, right? There you go. So that's double A. If I just go alpha A and hit enter, boom, up pops the number again. Okay? So calculate away. We now have this value stored. R2 is in A, and we can use it anytime we want. All right, now we need the surface area of this thing. It's actually called a frustum. Frustum. It's a truncated cone. In other words, you take a cone and you cut the top off it. And if you look around, you go online, look up frustum, you can find a formula for the surface area of a frustum and the volume, and actually little calculators online where you can work it out. Just give it the various numbers. Okay, but we can do this, right? And here's how we're going to do it. We're going to work out the surface area of the entire cone, right, with the 14 and the 10 and the root 96. We're going to work out the surface area of this smaller cone and subtract it off, but then we have to add on the top circle. Okay, so what do we got here? Do we got room? Yeah, okay, so let me do this. So surface area is equal to the surface area big cone minus the surface area, the lateral surface area of the little cone. Okay, surface of the big cone is going to include this base, which is fine. We need that. Surface area of the little cone we're going to subtract off. We don't want to include that base as part of it. We want to subtract off this part, and then we're going to go actually add back on the base of the little cone. So plus the surface area of the base of the little cone. Okay, ready? So surface area of the cone is pi rs. So pi r1 s1. Okay, let's just push this up a bit. Okay, and that's the lateral surface area of the whole thing. Plus, right, we're going to have to add on the base. So pi r1 squared. That's the area of this base. Minus, we just want the lateral surface area of this. So that's just the pi r2 s2, right, this 5 meter here, right, that guy, plus, and then we have to add on the base of the little cone, which is actually just the top part of our frustum, and that's going to be pi r2 squared. Okay, everything's labeled, everything's down here, so we got pi 10 times 14 plus pi 10 squared, right? That's the base. So this is a formula for the, if this part wasn't cut off, that would be a formula for the surface area of that entire cone. Minus, and we're going to take away the lateral surface area of this guy, so that's pi r2 is 3.571 dot dot dot. Remember, we stored that in A, so when we go to do our calculation, and S2 is 5 plus pi 3.571. Okay, and remember, we stored that in A, so we're going to use it multiple times. Okay, so that's why we stored it. So now, we could do a little simplifying if we like. We got 140 pi plus 100 pi minus this plus this, right? And I kind of worked it out a bit, but you don't have to. I got 17 point. I wouldn't do this if I were you. Okay, so as a matter of fact, you know what? Let's just go back to this line here, and let's plug that in. So let's move this guy over. Okay, ready. We have, let's clear. We have pi, second pi, times 10 times 14 plus, hang on, I was going to get in a comfy spot here, second pi times 10 squared minus second pi times A, right? 3.5 times 5 times 5 plus second pi times A squared. Okay? Remember, because we stuck that in A. Make life easy, right? Hit enter. Boom. 737.953. And no, it's okay. Well, rounding to the 10th, right? So to the 10th, we look here, look there, if I've got to round that up, so it'll be 738.0, and it's in meters, meters squared. Okay, wow, huh? Surface area. There actually is a formula for the surface area of a frustum. Frustum. Sometimes misspelled as frustrum. Frustrum. You can actually find an online calculator. You could throw it in and then go check our answer. Hey, did you get it right? Okay. Volume. For volumes, we need heights. Did we get heights? I think we have some heights hanging around up here. We got this height. We did not get this height. But this height will be the square root of 5 squared minus r2 squared. So h1 will be 96 and h2 will be this, right? We're just going to use this expression. And remember, r2 is in a, so we can use that when we go to calculate. Okay, so what we need the volume is equal to volume of the large cone minus the volume of the small cone, right? We don't need to worry about this. It's just all taken care of. The entire volume minus that volume. Let's make that L. Okay, 1/3 pi r1 squared h1 minus 1/3 pi r2 squared h2. Formula. Substitute 1/3 pi. R1 is 10 squared. H1 is the root of 96. Exact values. Never round. Yes, I'm going to hammer it all year, and all of next year, and all of the year after that. This is the 3.571 ... which is stored in a squared, right? And this is square root. I'm just going to throw an expression in, right? It's going to be 5 squared minus 3.571 ... squared, right? And we'll get to reuse. We're going to use a twice in here. Okay, calculator time. Let's clear this out so we can see. Okay, 1/3. So I'm going to go bracket 1 divided by 3. That's how I like to do my 1/3. And then I can just throw a pi next to it, and I can actually just throw a 10 squared next to it, right? Since the pi, anything written together will be multiplied, and then I can just throw a root next to it, root 96, right? But I need to get out of the root, so we got a right arrow out of the root. Minus 1/3 again. Now if you like, you can put in a times, right? Times pi times alpha a, right? So we need that r squared times the root of 5 squared minus alpha a squared. Okay, boom. Whole thing ready to go. Hit enter. 979.3. 979.3 meters cubed. Cubic meters. Okay, so it was a long one, right? But we're going to split this up because we're going to do like half each day and give you time to work on it. And really the most important thing here is you got to do a bunch of these, right? There's no way around it. There is no substitute for practice. Okay, see ya on the next one.